So the first thing we're going to do here is we're going to find the domain of our square root graph, okay? Oh yes, I forgot to mention. So our purpose right now is we're going to graph this square root equation, okay? So the first thing we're going to have to figure out is the domain. Now, as we saw before, the key restriction that faces us is that we cannot take the square root of a negative number. So what we're going to do is we're going to set the inside of the square root greater than or equal to 0 and see what range of x that gives us, okay? So to find the domain of the square root graph or function, we find what values of x make the inside of the square root non-negative. In our case, the inside of our square root is x minus 4. So I'm going to do that here. X minus 4 is non-negative if it is greater than or equal to 0. Okay? In other words, non-negative, I want you guys to notice this word, non-negative. What does that mean? That means positive or 0. Okay? It's either positive or it's 0. Okay? Yes. Okay. Now, when we have an inequality like this, we just solve it, okay? So this one is a very simple inequality. All we have to do to solve it is to add 4 to both sides. Now, of course, later we'll do more interesting ones, okay? But for right now, we can just do this one. So this is x bigger than or equal to positive 4, okay? Let's draw it on a number line, okay? So here, I put my number line. I know it's going to be 4, okay? I know that it's going to be filled in because it's greater than or equal to, okay? And since the x is bigger than the 4, then it's going to be shaded to the right, okay? And so now, I know since I'm going to the right, I'm going towards positive infinity. And so now I'm prepared to do my interval notation. So here what I'm going to do is, I'm going to put a bracket. Because I'm filled in, because this is equal, I'm going to put a bracket to indicate that I'm going to include the endpoint. The endpoint is going to be 4. Then, I know I'm going towards positive infinity, so it'll go to positive infinity, and then I put a parenthesis. So that is how I got my domain. Okay? 4, comma, infinity. Close parenthesis. Okay? Okay. So now, what we're going to do is we're going to start finding the points on our table. We're then going to get our x-intercepts and y-intercepts, and then we're going to get the range after we've graphed it. Okay, so let's do the next step. So now the first thing we're going to do, now that we've gotten that 4 is the endpoint of our domain, we're going to use it to as the first point of our table. So that's why I have 4x equals 4. I'm going to use this expression to calculate what the corresponding y must be. Y will be negative the square root of 4 for my x minus 4 plus 3. Now, what is 4 minus 4? 4 minus 4 is 0. So I'm going to have negative square root of 0 plus 3. What is the square root of 0? The square root of 0 is 0. What's the negative of 0? It's just 0. Plus 3, and so that's just, what's 0 plus 3? 3. So I know that the corresponding y value here is 3, okay? So now, as we mentioned before, we're not going to guesswork what our next x value is going to be. When we're going to graph this, we want to pick the best x values. Since we're taking square roots, we want to make the inside of the square root perfect squares. That way, it'll be easy for us to graph this on a graph paper. Now, as we saw, this value 4 made the inside of my square root 0. We recall, what is the next perfect square after 0? 1. So, I'm going to set my inside equal to 1. So, x minus 4 equals 1. If I have x minus 4 equals to 1, I can solve that for x. How? I add 4 and I add 4. And I get that x is equal to 5. Okay? Aha! Now I have my next x value. Okay? What do I do with this x value? I want to find the corresponding y value. So I evaluate my expression, I evaluate my equation with the x value 5. So y will equal to negative square root of 5 minus 4 plus 3 equals. Now, what is 5 minus 4? That's positive 1. So this will be the negative square root of 1 plus 3. Now, what is the square root of 1? That's just 1. Why? Because 1 times 1 is 1. So this is going to be negative 1 plus 3. What is negative 1 plus 3? Aha! It's 2. So, that becomes my y coordinate here on my table. What is my next perfect square? Okay, I know that 0 squared is 0. I know that 1 squared is 1. My next perfect square, 2 squared, that's 4. So I'm going to set the inside of this equal to 4. X equals, or, whoops, x minus 4 equals 4. Okay, so now I'm going to solve this for x. In this case, I'm going to add 4, and I get x equals 8. And then I'm going to evaluate this expression with x equals 8 to get my corresponding y coordinate. So y equals negative square root of 8 minus 4 plus 3. You have to also be very careful. I know you guys probably noticed, but I was very careful to make sure that all went inside the square root house. And so I want you guys to make sure of that too, because you don't want to make a mistake. Here, it'll be negative. What is 8 minus 4? 8 minus 4 is 2. So this will be this. 8 minus 4 is 4. So this will be 4. Okay, so we have the square root of 4. Okay. Then, what happens here? Well, we ask what's the square root of 4? So that's going to be 2. So it'll be negative 2 because of that negative on the outside. And then plus 3. What is negative 2 plus 3? Aha! It is positive 1. So I now know that for x equals 8, my y is 1. So I write that down here. And of course, I can go to my next perfect square, which will be 9, right? Because we saw that 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So I set the inside of my square root equal to 9 to find the right x value that will give us the nicest result. And I see that I get x is equal to 13, okay? Then I use this expression to get my corresponding y value. So y equals to negative square root of 13 minus 4 plus 3. And again, by design, 13 minus 4 is 9. So this is equal to negative square root of 9 plus 3. And then, what is the square root of 9? That's 3. Why? Because 3 times 3 is 9. Okay? So I get negative 3 plus 3. And what is that? That's 0. So I now know that for the x value 13, my y value is 0. So in other words, what I want you guys to, just to recap that, what this column of calculations told us is that the point 5, comma 2 is on the graph of my square root. What these calculations tell us is that the point 8, comma 1 is on the graph of the equation. Okay? And what these calculations tell us is that the point 13, comma 0 is on the graph of the equation. Okay? Okay, perfect. And so now, let me see here. Is this point special because it has the y equals 0? Interesting. We're going to discuss that right now. Yes. So basically, obviously, this point 13, 0 is interesting because its y is 0. If the y is 0, that means it must be a x-intercept. Okay? It's a beautiful thing. But now for completeness, we're going to double check. Okay, we're going to find the x-intercept of the equation by setting y equal to 0. And we're going to solve for x. And then we're going to find the y-intercept by setting x equal to 0 and solving for y. So let's do that together here. So here, I have this expression equals y. So I have negative the square root of x minus 4 plus 3 equals to 0. So basically, again, so why are we doing this? We're doing this because, number one, this is an opportunity to review the solving of square root equations. Number one. Number two, this is an opportunity for us to verify algebraically that there is no further x-intercepts. And number three, maybe if we were, maybe the problem might have stated not to graph this equation but to find the x-intercepts. We don't want to go through all this rigmarole, and we don't want to be guessing and checking to find the x-intercept. We just want to set up the equation and solve it. And so this way, if that was the real question, we could do it this way. And so without further ado, let's do this, okay? So the first thing I'm going to do here is, if I'm looking at this equation, I want to get the square root term by itself. Now, what I could do is I could subtract the 3 to the other side, okay? And I would have negative square root of x minus 4 equals negative 3. Then I would divide both sides by the negative 1, okay? But what I can also do is I can observe it for a moment and I can say, aha, yes, this is some expression in x, right? But if I think about it, for any value of x, this is just a number, right? So I can just add it to the other side, okay? And so then I'm left with 3 equals the square root of x minus 4, okay? And so just for the sake of convenience, I know that we're usually used to seeing things like this on the left, so I'm just going to rewrite it here, okay? But what I wanted you to observe there is that sometimes just a little bit of judicious thinking can help you solve an equation with fewer steps, and yeah. Now once we're here, what do we do? What is the operation that is the opposite of square rooting? Aha, we're going to square it. We're going to square both sides of this, okay? Okay. Now when we have this, when we have x minus 4 and we square root it and then we square it, the square undoes the effect of the square root, so we get x minus 4. In other words, when we square the square root house, the square root house goes away. What is 3 squared though? 3 squared, that's 3 times 3, that's 9. Aha. I add my 4 to the other side, I add my 4 to the other side, and I get that x is equal to 13. Okay? And of course that is precisely the x value of the x-intercept that we found basically in the course of making our table, okay? But of course it could have been that we had, it could have been that we didn't, it could have been that our table did not reveal this to us, so we would have had to have done it this way. It could have been that there was no x-intercept. There's a lot of possibilities related to those kind of scenarios, and so I again wanted to just walk you through this so we don't forget that we can always find the x-intercept explicitly without having to make a table. Okay, we can just solve for it explicitly, and Yes. Anyway, so now we're going to talk about finding the y-intercept of the graph of the equation. Okay? In order to do that, we need to set x equal to 0 and solve for y. Now, if you're looking at this, at this equation, okay? This equation we already saw has domain from 4 to infinity. What does that mean? That means specifically that no value of x that is less than 4 will be a number. No value of x less than 4 will make the expression x minus 4 into a positive number, and therefore none of the x values to the left of 4 will we will not be able to take the square root of any number that is produced when we let x be anything less than negative, when we let x be any number to the left of 4. So we can already eliminate the possibility of a y-intercept. Okay, because we see that x equals 0 is outside of the domain. Okay, and so yes, so we can okay, right, and so basically what I wanted you to observe there is that don't lose sight of the information you already have. And sometimes, if you see that information, you can get an insight that allows you to essentially avoid a calculation, or realize that a calculation may not give you anything you didn't know already. And of course, we saw that because of the way we calculated the domain, namely, we found those x values that made the inside of this house positive or 0. In other words, non-negative, positive or 0, because that's when we can take the square root. We can suppose, therefore, that if we were to plug in x equals 0, that it would make the inside negative, right? And we can see that here. So y equals negative square root of 0 minus 4 plus 3, right? If I'm trying to find the y-intercept of the equation's graph, I set x equals to 0 and solve for y. I can see that indeed it becomes 0 minus 4 on the inside. That's going to be negative square root of negative 4 plus 3. And we can see that that is not the situation that we're dealing with here. Now again, we want to remember that when we're graphing the absolute value, when we're graphing the square root here, we're looking at the square root as a real valued function, and so that's why taking the square root of negative 4 is not considered, or taking the square root of a negative number here is not considered, because we're not looking at it we're looking at it specifically as a function from real numbers into real numbers. Okay, so now with that behind us, we can finally draw our graph and determine the range. So now let's do the graph. Okay, so again, as usual, I want you guys to notice that the first thing we're going to do before we draw this graph is we're going to look at our x values and our y values here to try and figure out what part of the x and y axis. Okay, so what we're going to do is we're going to look at our x and y values to try and figure out what part of the xy axis to draw. We can see that we only have positive x values from 4 onwards, and we only have positive y's. So literally, what we can do is we can draw our y-axis like this, and then we can draw our x-axis like this. In other words, the first quadrant, and that's basically all we need. And let me see here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oops, I made them too long. Let's say 13 over here, all cheating. Oh my god. And then at 4 we have 3, so let's say 1, 2, 3. Okay. 1, 2, 3, 4 along my x. I'm going to have the value 3. So I'm going to go, so 4, 3, I'm going to go 4 to the right along the x, and then 3 up. So let me see. Like about right there, right? 5, 2. Right, this is the point 5, comma 2. So that means x coordinate 5, y value 2. So I'm going to go 5, and then I'm going to go 2. So it's going to be right there. Then I have the point 8, 1. So that means I'm going to go 8 along the x and 1 along the y, right? So that's going to be like right there. So let me see. And then finally, of course, 13 is at 0. So I'm going to put it right there. And this, oh yes, this is looking a lot better. Oh my god. No, still, this, I swear, this has to rank right up there with some of the worst graphs I've ever drawn. I apologize for that. Now, in all seriousness, we can see that it's going to go from 3 down forever. So, since going down means negative infinity, the range of this function, of this square root function, will be from negative infinity to 3. And I'm going to include the 3. Okay? And so with that, we have graphed this square root, with this square root equation, and I look forward to seeing you again soon. Thank you.